Number 128 in your classwork for circles tells you that we have a figure that has two semicircles, one with center K and one with center M. The semicircles are tangent to each other at J, and QN is a tangent to both circles at N and O. We're given the lengths of KL, so KL is equal to 12. So this distance is 12. And if this is a radius, because it lies on the diameter, if there are semicircles, then this length kj must also be a radius, so that will also be equal to 12. Then we know that jp is 12. So if jp is 12, this distance is 12, and that is a diameter because it is a semicircle, then the radius would be half of that, which would be 6. So we have all of our parts labeled so far. And they ask, what is the length of OQ? So OQ, if we draw a radius from K to O, and we know this radius is equal to 12, then OQ is a side of a right triangle formed with this tangent line, this radius, because radius point touching at the point of tangency will form a 90-degree angle with the tangent line. So that would be a side length. This radius would be another side length. And then the hypotenuse would be this total side length from Q to K. So in order to solve for that side length, this hypotenuse, H, we need to find PQ here. So PQ we can solve for with a proportion, actually. So if we take a look at our two semicircles, if we draw the radiuses to both O and N, then we notice that we have a congruent angle over here. Also, we have a common angle shared here at Q. And so this means that these two triangles are similar. So we can set up a proportion between their corresponding sides. So I'm going to set up a proportion between, if this, let me just label MN as 6 because that's a radius. So if we set a proportion between the larger circle radius, so that would be 12 over the hypotenuse, which would be 12 plus 12 plus this PQ, so that would be 24 plus PQ, equals the corresponding side, which would be 6 of the smaller triangle, plus this 6 plus PQ. We can now solve for PQ, so cross multiplying, we get 72 plus 12 PQ equals 144 plus 6 PQ. Then subtracting 6 PQ, so we have 6 PQ equals subtracting 72, we have 72. So then PQ equals 12. This is a key step to solving this problem. So we know now that PQ equals 12. So our hypotenuse of the larger triangle is this radius, 12, plus this diameter, another 12, plus this PQ, which is 12. So that would be 3 times 12, which is 36. And OQ now becomes a side of a right triangle. So that side squared plus the other side squared, which is this radius, 12 squared, equals 36 squared. Now plugging into our calculator, so we have OQ squared is equal to 36 squared minus 12 squared. So that would be OQ is equal to the square root of 36 squared, which is 1,296 minus 144. 24, and the square root of that would give us a length of OQ equal to 33.94, rounding to the nearest hundredth.